Hello guys, so this is today's problem of the day, split array largest sum. So here we are given an array of n elements and a number k, and we have to split that given array into k subarrays such that the maximum subarray sum achievable out of those k subarrays. For example, in this example given, we have to split this array into 3 subarrays. So k is equal to 3 here, so we have to split into 3 subarrays, right? So the first split we did at 2, the next is split at 3, so we achieved our 3 subarrays. And if we see the sum of this first subarray is 3, then this sum is also 3, and this sum is 4. So the maximum out of these 3 is 4, and we have to make this value minimum. So the answer for this is 4. For example, if we have let's say if we take our sum as 6, then if the sum would have been 6, then 2 plus 3 3 and 3 6, then there would have been two splits, right? One is split at 3 and another element as 4. So we have to given the number of subarrays we can make, we have to minimize this sum. For example, if you take here sum is equal to 5, then sum is equal to 5 we'll have to split at 2 2 and 3, then again at 3 and 4. So the number of split we again got is 3, but the sum is 5. But for sum is equal to 4, we can achieve this minimum number. So for this case our answer is 4. So what we can do is uh, yeah, so what can be our sum, what can be the range of our sum? So the minimum partition that will require will be the maximum element out of this subarray, because if we take our sum less than 4, let's say if we take our sum less than 3, then we'll never be able to have this 4 in our one of the subarrays, right? So the minimum sum that we can have is the maximum element of our array. And what is the maximum sum that we can have? That will be like if we sum all these 4 3 7 2 9 1 10. So if our sum would have been 10, then there would have been only one split, right? So maximum is our sum of our all the elements of our array. Yeah. So now what we can do is so this is our range, this can be our start, or let's say low, then this can be our high. So right now what we can do is, for a particular sum we can see that how many splits we are getting. So let's say for our, if we take our sum as 6, then we'll get 2 splits, but we require 3 splits. That means we'll have to reduce our sum. So we'll reduce our sum and then again check if what are the number of splits that you are getting. Let's say if we take our, not for let's say for this case, if we take our, so this is not a valid example, let me write one more example. I meant to say that if we take less sum, suppose 2, but we cannot take 2 in this case, but just for the sake of understanding, if we take 2 and we get more number of splits, and we require let's say if we require 4 number of splits. Yeah, so what I meant to say was that if this is our array, and if k is given as 1 to us, like we can only split once, and if we take our sum as 6, then for 6 we'll get 2 splits, like we can split right here. So we are getting 2 splits, but we require only 1 split. So in that case we can increase our sum, like we can make it 7. For 7 also we'll get 3 2 5 1 6 2 splits, then you can make it a, well, like so on. So what we can do is, instead of doing it linearly, we can do it with the help of binary search, right? So we can apply binary search from low range till high range, and we can for the every sum that we are getting, we can calculate the number of splits, and according to the number of splits we can increase our low range, or we can decrease our high range. Okay, so let's code for this. First, for a given sum we have to calculate the number of splits. So for a given range we can calculate our number of splits. So what we can do is int, we'll just pass our sum here, and sorry for today uploading this video as late, as busy in some work today. If there is any doubt you can ask me in the comments. So if our current sum plus our given array is within our required sum, so we'll increase our current sum value, and we need not split for now. And if our current sum plus our given element is exceeding the sum value, then we have to increase our split. It means we need to split that array and initialize our current sum with current array position, current array element, right? And return this count value from here. And this is initialized to 1 because when we are splitting it once, that means we need to return 2 splits, right? So that's why this initializes 1. And I'll apply binary search here. First we'll calculate our max element and our array sum. So that we can have a range. So for just simple maximum element calculation, and then we'll our sum to this element. And then we'll apply binary search on this. Our low range is our this maximum element, and our high range is our sum of the array, right? And now if I binary search on this, and we'll take some save variable so that we can save our sum. So till our low is less than equal to high, we calculate our mid, and then we'll calculate our splits. This is our sum, this is our current sum. So for this current sum we'll calculate our splits, and that will be array, will pass what are the parameters, array and sum. So sum is our mid, so we'll get the number of splits that we are getting for this, right? And if our splits that we are getting is less than equal to the number of required splits, so that means we can reduce our sum value. So in order to reduce our sum value, we'll just write is equal to -1, and we'll save this current sum, and else we will increase our sum. Oh, sorry. Right, and we'll return this save sum value. So let's see It's working fine. Some error is there. No, does not name it a 55. Oh, sorry. This is the incorrect answer for this. Let's try to submit this and I'll see your time complexity. Okay, so this is here submitted. So yeah, so for this, let's see your time complexity. So you're going from low to high, and this is logo, and high is our some of the elements. So we can say this is log of some of the array. Let's write it time. This is a log of the sum of array, and for each sum we are taking order of n time for calculating its number of splits. So this is this. So this is the time complexity of this solution. I hope you understood it. If there are any doubts, you can ask me in the comments, and we'll be back tomorrow with the new UTD. Thank you.